Can you not see it?
Oh, no, we can see it. We can see it. We can see it.
Oh,
Uh,
okay.
I see it.
yeah. This is Lab 10, Group 58 discussion.
All right. So this is lab 10 about the angular momentum principle. And in this lab, we had to kind of construct a device with our IO lab kit, roll it down a ramp, and then estimate its moment of inertia based on various values that we obtained. So I guess I'll just go to the first discussion question, which is, it says in the discussion board, oh, share your ideas with your team regarding the slope of the ramp you will use before collecting data. Come to a consensus about what angle you will use. Well,
I guess it's like a regular ramp, right? Like a 90-degree angle. It was perfect 45, 45, 90, right?
yeah, I guess.
Wait, there's
That's not, I mean, I
like
didn't do a
binder.
45-degree ramp because that was too steep.
Oh, no, like some, wait. Oh, yeah. I don't know. It just depends on the binder. I didn't really measure
Mine
that.
was like 20.
I don't know.
something.
Honestly, I didn't see this, but I guess you guys can kind of just look at my work and see if you like did the same thing. Because I mean, we would have different values, but I don't think it's gonna be like that big of a difference, right?
Yeah.
All right. Well, we'll just move on. It's not a big deal. There's my ramp and device. It's pretty sick. Next discussion question. Sheesh. Okay. So it says compare with your team members' calculations and results for 4, 6, 8, 10, and 11. And after agreeing in rationale, discuss the reasons for the differences between your results. All right. So 4, 6, 8, 10, and 11.
We use different angles and different tapes, probably. So
Yeah.
that's the only answer.
I guess we'll just go through it and you guys can tell me if you kind of use the same method. And then we're obviously going to have different stuff because all of our tape rolls are different and
Yeah. I
our
mean,
ramps were a little different and there's a lot of differences.
like it's
But
basically like two separate or three different types of experiments. I don't know how many changes.
yeah. Well, question 4, it's just asking from the graph above, determine the angular acceleration of the object as it rolled down the incline. I calculated it here where it's about 15.1 up here, and it took 0.91 seconds, which is 16.6 rads per second. Or you can literally pull it right off the graph right here. So I don't know why they want us to calculate it when the device does it for us, but just so everyone's happy, I went ahead and showed my calculations clearly anyways.
Yeah.
Sounds good.
Number 6 next. It's asking about the mass of the composite object. Yeah, this one pretty self-explanatory. I just added the mass of the cart plus the mass of the 2 tape rolls and got 0.18 kilograms.
Very hard
I
question.
don't really think that's too tough to mess up, but sure. Next was 8, right?
Yeah.
So this one's asking, what's the force acting on the composite object down the inclined plane? So I kind of had to look this up because I wasn't really sure how to go about it. Found this really helpful video. This guy gave this good explanation that, like, because of the way the tape is going to roll, technically the only thing that's applying torque to the system is the friction. So you kind of have to solve for that to answer the rest of it. And so we know that F is equal to mg sine theta minus the friction, which is equal to the mass times the acceleration at the bottom. So we can plug in all these values. The only thing we don't know is friction. And then this 0.83 is just the 16.6 that I found up there, converted. And then we find that the force is equal to 0.15 newtons. And then for 10, because it kind of goes together, it's asking what's the torque acting on the composite object. So I just said R times friction sine theta, because that's the formula for torque. It would be R S sine theta. And then plug in all the values, and I got 0.0137 newtons per meter.
That's right.
And then what was the other question?
11.
11. Yeah.
Oh, 11? Wait,
Yeah, you skip past it.
oh, I'm tripping. Oh, hold on. I got to, I have work for this. I forgot to add it in. There we go. Okay. So the experimentally determined moment of inertia. So I just set torque equal to I alpha. And we know that the acceleration is equal to R times alpha. And so we know that alpha is equal to A over R. And so we have our force times our radius is equal to I acceleration over radius. Substitute in the values. And then I've experimentally determined the moment of inertia to be 0.0165. And then I also have work for 13, like where you do the calculated one, but I think I forgot to email it to myself. But anyways,
Yeah, your 11 looks right.
yeah.
That's why I do that.
And then question 18 says to compare calculations to 13, 14, 15, and 17. So, hold on. 1 second, guys. Okay, yeah, so I'll add this in. I don't know why I didn't take a picture of it. I don't know how well you guys are gonna be able to see this. Can you see that at all?
Yeah, we can see it.
Yeah, so pretty much
Yep.
so this is for 13 where I calculate the moment of inertia. So I just have the moment of inertia of a rectangular prism, which I pulled this formula right off that like link right there. I substituted in the values, and then I've got 3.86 times 10 to the minus 5. And then we also needed to add the moments of inertia of the two tape rules, which we know is 1/2 m. And then instead of r squared, I used the one where it was like a thicker hoop. So you take the first radius squared plus the second radius squared. And then I found that the moment of inertia of a single tape roll is 9.765 times 10 to the minus 5. So that would be 14. And then 15, I just added the rectangular prism and then 2 of the tape rolls. And I got 2.34 times 10 to the minus 4. And then 16, I found the percent error, which is pretty high, I won't lie. But 17, where it asks what are the reasons for the discrepancy, I said, I think that while the discrepancy looks high, it's really not that bad considering all the sources of error that there could be in this experiment. Obviously, the objects we are measuring are very small, and the experimental values we obtain are based on a very short roll down a not so perfect ramp. Is that also the calculated moment of inertia is based on objects with uniform density, which the lab cart is not, and who knows if the tape rolls are either. That's why there's such a discrepancy. Would you guys agree with that? I mean, we're
Yeah.
not dealing
Yeah.
with perfectly uniform objects here.
Yeah.
So I
I
think
think
even
the
if we
density
did
is the
the
biggest part.
experiment, yeah, I mean, even if we did the experiment like 20 times, we'd probably never get it dead on.
And if you do it 20 times, your numbers are still gonna be different, like almost a lot of the time.
Yeah, exactly. But honestly, yeah, that's what I have. And then I don't know why I didn't add these pictures in for this, but I'll add it in before I submit it, obviously. But yeah, you guys have anything you want to say about your results, or you think we covered it all, or what?
I think we covered it all. Yeah.
Okay, I agree.
I will end.